All right, so in section 1.6, I'm going to show you just a couple applications that you can use linear algebra for. And so, there's more and everything, but these are just like this chemistry one. You guys all took chemistry. Maybe you're taking AP chemistry. This is just like a basic thing you do in chemistry, is balancing an equation. So I'll show you that one. And then on the back, there's one about what's called network flow. And so, I don't know, the economics one was kind of boring, so I just skipped over that one. But anyway, here we go. So when you balance a chemical equation, you need to find coefficients for your pieces here so that you're balancing it. I don't know how to do this in the chemistry way, but you guys probably learned that in chemistry already. But basically, what we have to find whole numbers for these spots here, so that the total numbers of carbon, hydrogen, oxygen atoms on the left match the corresponding numbers of atoms on the right. Okay, so because atoms are neither destroyed nor created in a reaction, all right, so here's how we can use matrices. So first you have to kind of organize your items. So we got carbon, hydrogen, and oxygen, right? So we're going to go ahead and put our matrices in order like this: carbon, hydrogen, and oxygen. All right, so I'm going to write this equation in that way. So I have x1 is multiplied by 3 carbons, 8 hydrogens, and no oxygen. So that'll be the matrix 3, 8, 0. All right, plus I have x2, whoops, and then this guy is 2 oxygens, but none of the others. Okay, and this has to equal x3 times carbon, no hydrogen, 2 oxygens, plus x4, H2. So let's see, so nothing, 2, and 1. Okay, so we have this equation now. So now what we're going to do is pull everything to the left. So you'll notice I'll have x1, I'll have 3, 8, 0, plus x2, I'll have 0, 0, 2, minus x3 and 1, 0, 2, minus, pulling it over, x4 and 0, 2, 1, all equal to 0. So we are going to make this into a matrix, into a homogeneous system of equations. All right, so here we go. So these negatives right here, so basically I'm going to like put a plus and then apply the negative inside here. Plus, apply the negative here and here. Okay, so you can see we have a matrix. I have zeros on the right hand side. I have 4 things, so 3, 8, 0 is my first column. I got 0, 0, 2, negative 1, 0, negative 2, and 0, negative 2, negative 1. All right, so you put that matrix in your calculator. You don't even have to put the column of zeros because those are never going to change. But when you ref it, it becomes this. Okay, and so I did not put the zeros in here. So there is a column of zeros over here. I just didn't put it when I typed it. So this is our solution. So let's write our solution to our system. So I have x1 is equal to a quarter. Well, so when I look at it first, actually, x1, x2, x3, and x4. x4 is free. He doesn't have a pivot. So x4 equals x4. x1 is a quarter, so positive 1/4 times x4. x2 is 5/4 times x4. And x3 is 3/4 x4. So you can pick x4 for whatever you want it to be. And remember, when you do your chemical equations, you always want whole numbers right here. All right, you never want fractions because you can't have a piece of something like that. So I just need to pick a number for x4 so that all these fractions disappear. So I think what I will do is I'll pick 4. So x4 is 4, which means that x3 is 3, which means that x2 is 5, and x1 is 1. And so 1, 5, 3, 4 are my numbers I will put in front. So 1, 5, 3, and 4. So that's super cool, right? And so, if you had to do a bunch of those things, then obviously this would be probably faster if you set up a little matrix with everything and pop it right in there and get your solution. Okay. All right, so the other one, the last thing we're going to do, and sorry about this copy machine here, but this is for something called network flow. And so it's a study of the flow of some quantity through a network, such as like monitoring the pattern of traffic flow, like in a grid of city streets, all right? Or maybe you're modeling the current flow through electrical circuits, all right? So we're gonna do the city, all right? So a network consists of points called junctions, or nodes you call them in some more fancy problems, with lines or arcs called branches connecting some or all of the junctions. All right, so the direction of the flow is indicated with little arrows, like these little arrows here. All right, and the flow is either shown or denoted by a variable. All right, so the key assumption in network flow is that the total flow into the network equals a total flow out of the network. So we're going to see that in this picture here. So we're going to assume that everybody coming into the city is going to equal everybody coming out, leaving the city. And so that'll be like a major assumption, like down here. Okay, so like if you saw this right here, you see 45 is flowing into this little network here. So 45 has to equal, because 45 is coming in, has to equal all these three things that are added together coming out. So you can make up that little equation. So what you're going to be doing is looking like kind of like an intersection, right? When 45 comes into this intersection, it flows out in three different ways, but it's those things added together. Okay, so we're going to basically be making an equation for each intersection. So look at intersection A. All right, 500's coming in, 300's coming in, but x1 and x2 are coming out. So x1 plus x2 has to equal 800. Okay, so that's where we're getting this equation over here. All right, so I got x1 plus x2 equals 800. Okay, all right. So, oops, I didn't mean to write. I'm sorry. I didn't mean to write that right there. We'll just kind of like put it over here. x1 plus x2 equals 800. All right. So on the next one, let's look at situation intersection B. So B, what's coming in? x2 is coming in. x4 is coming in, so x2 and x4 are coming in have to equal x3 and 300 leaving. So you see that right there? So we're going to rearrange these. I want all my variables on one side. So I want x2 minus x3, I'm bringing this one over, plus x4 have to equal 300. So just to prep. All right, here, C, I got x3 and x4 leaving. Also, and these guys coming in. So 500 coming in has to equal x4 and x3. So good, 500, x4 and x4 and x5. I can't see. All right, so I got x4 plus x5 equals 500. All right, and the last one, letter D. Let's see, we got x1 and x5 coming in and 600 leaving. So there's that equation. So x1 plus x5 equals 600. Now, so that's what I'm seeing in the picture, but then you have to look at the picture as a whole. So you have to look at the outer edges. So this, and that. That's everybody that can come or leave or come in. And this is actually like downtown Baltimore, right? Like the city streets in downtown Baltimore. All right, so let's see. So I would say that I have, let's do everybody coming in. So 500 in, plus what else is coming in? 300, plus 100, plus 400. Has to equal, let's see, what's leaving. So 300 plus x3 plus 600. Okay, so if I solve that right there, I'm actually going to get a value for x3. I get that x3, I got these two, that's 900. If you add these up and move everything around, you end up getting x3 equals 400. Okay, so that's actually like, you know, something I can solve. All right, so now we're going to set this up in a system of equations. All right, so I have my system of equations here actually, so I think I'll just go ahead and use this space here to draw my matrix. All right, so I have all the way up to x5, right? So I have x1 and 2 are both 1, and 3, 4, 5 don't exist. This equals 800. All right, for the next problem, I have x1 is missing, but x2 is 1, x3 is -1, x4 is 1. I don't have x5, 300. All right, the next equation, I have x4 and 5, so that's 1 and 1, 500. And then this one, 1 and 5, so 1, 2, 3, 4, 5 is 600. Oops, I need a little bit more space because we do have to also put in our constraint equation down here. It says x3 is 400, so here's x3, and I'll put 400. All right, so this is my matrix that I have to go and row reduce. So when I do that, I'm going to write that one over here. Let's see if I can squeeze it in there. All right, so when I row reduce that in my calculator, I get 1, 3, 4 zeros. Oh, wait. 1, 2, 3, 4, 5. 1, 2, 3. Yeah, sorry. Wait. 1, 2, 3 zeros. I'm sorry. So many things in a row. It's like kind of obnoxious. All right. So 3 zeros and a 1 and 600. I get 0, 1, 0, 0, negative 1 and 200. And then 0, 0, 1, 0, 0, 400. 3 zeros, 1, 1, and 500. And one last little row of all zeros, actually. Okay, so let's write our answers. So x1, that's this guy right here. Also, let's go ahead and see which one's free. All right, looks like x5 is free, right? So x5 equals x5. That's pickable. All right, and so let's do this. x1 is negative x5 plus 600. Okay, x2 is positive x5 plus 200. x3 is 400. We already knew that. x4 is negative x5 plus 500. And x5 is x5. All right, so the last thing to figure out right here, a negative flow in a network branch corresponds to flow in the direction opposite to that shown in the model. So since streets in this problem are only one way, none of the variables here can be negative. So like all these streets are just like one way, like a bunch of one-way streets, this way, that way, this way, that way. All right, so nothing can be negative here. So I just would have to look at this and say to myself, this one right here, these two problems right here. In here, x5 couldn't be any bigger than 600, so that this part x1 can't be negative. All right, so that would be 600, x5 can't be, but actually this one's a little bit lower. x5 is going to have to stay smaller than 500. It could be equal to 500, I guess. So that's the one constraint you have, but this is your answer. Once you pick x5, everything else falls into place because everything depends on that. And so that's that. So you would go ahead and mention this, but there would be your answer to your system. And so once you pick a value for x5, you go ahead and find the rest, and then you'd have your solution to your system. All right, that's it. And we will practice this next time in class and do a few problems on it. Okay, bye-bye. So don't do this tonight. We'll do it in class, and we'll also do a couple others. Bye-bye.